So if you just say 85% of the variation is explained, that's not going to be good enough. 85% of the variation in what? In amount spent on vacation can be explained by annual income. Always response variable first, and then explanatory variable. This is a common theme. Context. You have to put the answer in context in order to get full credit. Okay, so before we switch over to number 2, any questions? Questions? I'm waiting for you to unmute yourself and ask a question. I'm looking in the chat and I'm not seeing anything. Okay, here we go. Number 2. So number 2, we're talking about different things than we would be if we were covering all 9 units that we could possibly need to know for the AP exam. There's a good chance that they'll show you something like this, where you have to figure out the linear regression equation based off of this more than there is that they're going to ask you to do it in the calculator if the official position is that you don't need a calculator, right? So here are 65 data points from high school seniors at a certain school, let's say Pascal. We've got an explanatory variable foot length and a response variable height. Theoretically, based on the line of best fit, as your foot length increases, so will your height. Okay, so on here, there's really only, even though there's all this gobbledygook over here, there's only 4 numbers that we need. If we were going all the way to unit 9 and doing hypothesis tests and confidence intervals for the true slope of a regression line, we would need all this t-value, p-value, SE coefficient stuff. We don't need that here, okay? All we need to be able to do is look at this and identify, for this line of best fit, what is the slope and what is the y-intercept. And even if you have an oh poo-poo moment on the day of the test, you're going to have your book, but you're going to be better off if you spend less time thumbing through your book looking for stuff and more time actually answering the problem and putting it in context and including lots of detail and everything, right? So foot length is the explanatory variable, right? We know our equation is going to be predicted y, in this case predicted height, equals the y-intercept plus the slope times the foot length. Okay, so foot length is our explanatory variable. Okay, coefficients, that means the number in front. Which one of these is the slope and y?
The 2.599 is the slope.
Right, because that's the coefficient of the explanatory variable. So even if you see this on the afternoon of the test and you're like, man, I do not remember how to figure out which one of these is which, okay, just use some common sense. You know what a coefficient is. That's Algebra 1 class. All right, so that's going to give us, and I'm going to switch over now to work out part A on a separate sheet of paper. Because what they're asking us in part A is, let me make sure I know what they're asking us about. They're saying, calculate and interpret the residual for the high school senior with a foot length of 20 centimeters and a height of 160 centimeters. So that's this person right here, right? So what do we know about residuals? How do you calculate a residual?
RAP. So residual equals actual minus predicted.
RAP, actual minus predicted, right? I'm pulling up my document here. It's a little slow. I should have had that up already, sorry. So the residual equals actual minus predicted. Actual y minus predicted y. Come on, document camera. Where are you? Sorry, y'all. Okay, there you are. I want to show you. There we go. All right, cool. So another way that we could put that is we could say that the residual is y, the real y value minus the y hat value. Okay, we know how to find the y hat value. That is the regression equation, right? Y hat equals 105.08 plus 2.599 times x. If you just write it down like this, if they ask you for the regression equation, you're missing out on something. You're missing out on context. So you've got to say what y hat means. Y hat is the predicted height in centimeters, and x is the foot length in centimeters for students at this particular high school. All right, so we know part of the story already. We know that this particular person's actual height is 160 centimeters, right? How can we find their predicted height?
We can plug in our independent variable into the equation we got.
Which is what, Peter?
The 2.566 times, or 2.599 plus 105.8, where you multiply the 2.5 times your independent variable.
Right. We're told some facts about this person. We're told that their foot length is, in reality, 20 centimeters. So, yep, it's just plug and chug. You chug out 157.06. So that residual comes out to be 2.94 centimeters. Okay, since this is a positive value, what is that telling us about this person's height compared to what we predicted?
Well, if we know their actual height, we can subtract actual from predicted to find the residual.
So is that like, did we guess too low or guess too high compared to what the truth about them is?
Too
Too
low.
low.
Right. This student's height is 2.94 centimeters above the predicted value from the regression line. The actual text from the College Board answer key is the high school senior is 2.94 centimeters taller than expected based on his or her foot length. So from the prediction line based on foot length, we can add some extra context there. Okay, so that's the residual, not on the formula chart, but easy to remember. So let's keep on going. Let's look at part B. What's going on in part B? Part B is asking us to interpret the standard deviation of the residuals. The actual text of the problem says the standard deviation of the residuals is S equals 5.9. So that is this value right here. So these four values are all that we need here. R squared, that's the coefficient of determination. We saw that in number 1. Standard deviation of the residuals. Okay, so let's think through, in case we have another oh poo-poo moment the day of the exam and we don't want to dig through our textbook trying to figure out what this means. Standard deviation usually measures distance from the mean, right? But we saw in part A, when we were talking about the residual, we saw that a A residual measures the distance from the regression line. So visually, what a residual is doing is it's saying, we calculated the residual for this person, right? They are, in reality, almost 3 centimeters taller than we would have predicted. This person is way taller than we would have predicted. This person is way taller than we would have predicted. This person is a little bit shorter than we predicted. Same with this person. This person is way shorter than we predicted. So since standard deviation is measuring the typical distance, when you're looking at a list of values, it's measuring the typical distance from the mean, right? But here we've got 2 different values. We've got all the foot lengths and all the heights. So it's going to measure the typical distance not from the mean, but from the regression line. The actual heights for the high school seniors typically vary by about 5.9 centimeters from the heights predicted by the least squares regression line using x equals foot length. So in order to get full credit for this problem, you need to contrast the actual y values with the predicted y values. That's a residual, right? Your interpretation needs context, 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 context. Anytime you're in, the whole test is going to be free response, right? You're going to be able to get partial credit just for putting the context of the problem in your answer. Don't leave that easy money on the table. Cash in on those points. And then the interpretation includes the idea that the standard deviation measures a typical distance, or you could also think of that as an average distance. So before we switch to review mode on part C and part D, I think, and I'm still scouring like AP stats teaching message boards to find out what official messages are coming from the College Board. You're way more likely to get the regression line here than from a calculator, okay? So know what these values mean and know how to think through what those mean. Okay, so on part C, it's switching gears to something that's really, really great to review, the normal distribution. Assume the distribution of residuals is approximately normal with mean 0 centimeters and standard deviation 5.9 centimeters. What percent of the residuals are greater than 8 centimeters? I would really expect there to be a question about the normal distribution somewhere on the AP exam, because that's like a huge thing in this class, right? And every time they grade a normal distribution problem on the AP exam, there's 3 things you need. You need the boundary and direction. So in other words, you need to draw a picture and shade in where on that picture you're finding the area of that represents your answer, okay? So very, very important to have your mean right here in the middle. We're going 3 standard deviations above. We're going 3 standard deviations below. I'm about to switch over to the document camera to show you kind of a streamlined version of this. We want to be higher than 8 centimeters. Okay. So day of test, you're trying to answer as much as you can in the speediest time possible. That is so blurry. So if you want to save yourself a little bit of time and not necessarily go all 3 standard deviations above and all 3 standard deviations below, come on, document camera, you can do it. There we go. What you could do is just kind of give yourself an idea of like, okay, what do I expect my calculation to be when I do this number minus the mean over the standard deviation. I expect it to be between 1 and 2 standard deviations above the mean. And that's what you're shading right there. So we basically want to find the probability that our residual is greater than 8 centimeters. What do we call the variable that tells us how many standard deviations above the mean we are? One of the most important formulas that we want to have tucked away up in here.
Z-score?
Z-score, thank you, Adrian. Yep, so the Z-score formula is X minus the mean divided by the standard deviation. If you show the work with the Z-score, then you're going to get credit for telling them, hey, I know what the mean is, and hey, I know what the standard deviation is. Okay, so when you work that out, you get that that's 1.36 standard deviations above the mean. So now it boils down to what's the probability that in a normal distribution, you pick a randomly selected point and you're more than 1.36 standard deviations above the mean. We're gonna focus on using the tables more so than using the calculator, since the party line is you don't need a calculator.
Is there an official place we can find the tables?
If you go to Google Classroom, I've posted, like in the classwork tab, second from the top, I posted the formula chart. So I think they said, like, be sure that you've downloaded that ahead of time, because normally for a paper and pencil exam, it would be in the test book, but you're not going to have a test book. You're going to have a computer. Very, very strange situation, but it is what it is, right? So actually, I didn't want to show you that. I wanted to show you this. Okay, so 1.3, and then the hundredths place is 0.06. Okay, so that 0.9131, that can't be the answer. That doesn't make any sense. What do we need to do in order to get the answer? Oh yes, somebody is answering in the chat. Subtract that from 1, that's right. Yes, that's very good. Thank you, Alex and Elijah. So that's going to give us, no. 1 minus, no. Come on, Mr. Spitzies. There we go, there we go. 1 minus, that is going to be the final answer, which is 0.0869. And so you want to put your answer in context. About 9% of the residuals are greater than 8 centimeters. So part D is kind of tying parts A and C together. Part D says, based on your response to part A, would it be surprising to randomly select a high school senior from the high school with a foot length of 20 centimeters and a height greater than 165 centimeters? Well, where did, why do you think they picked 20 centimeters? Because we already know that the residual, we already know the predicted Y value for a student with a foot length of 20 centimeters is, right? We got that that was 157.06, right? Okay, this is a different student. This student's height in part D is 165. So that's like ish 8 centimeters, right? We calculated the probability of getting a residual that's 8 centimeters or higher in part C, right? And so the question becomes, then, how surprising is a 9% probability? Their answer is no. A high school senior with a foot length of 20 centimeters is expected to be this value that we got from part A. So that would give us a residual of about 8. they're saying, no, that's not surprising because about 9% of the time that will happen. What's the dividing line between no, this is not surprising, and this probability is so low that I'm like completely shocked and taken aback that this has happened?
It's 5%, right?
5%. That is why the most common value that we use to decide, hey, this p-value is low, we reject the null hypothesis, or this p-value is not so low, I'm going to fail to reject the null hypothesis. That's why 0.05 is that most common significance level. I can still spell, I promise. Significance. That's better. Okay. All right, so that's the questions from the College Board. Do you have questions before we shift gears a little bit? I saw something in the chat and I'm having a hard time pulling the chat up. All right, if I'm not getting your chat question, then feel free to unmute yourself and speak up. I'm gonna figure this out eventually. Okay, so what I've been doing whenever I've got kind of low impact work, like I had to add all my students into Edgenuity, and that was just kind of like, once you figure out how to do that, you do it over and over again. I've been putting on YouTube videos from Late Night with Conan O'Brien episodes from the 90s. I know he's still on TBS technically, but there's just nothing like Late Night with Conan O'Brien. He was much, much funnier on NBC. Okay, so here's my joke to transition us to talking about correlation in real world scenarios, done in the voice of Late Night with Conan O'Brien. Man, kind of a sad story in the news recently. The driver was okay, but an 18-wheeler carrying only toilet paper was overturned on a highway outside of Dallas. Yeah, it turns out that for this accident, it wasn't caused by another vehicle, but actually by angry Walmart shoppers. They said, "Give me that toilet paper. Give it to me." Okay, so here are the actual pictures from this 18-wheeler accident. There was another joke that I heard on a news story about this that said it was burned before it could be flushed, right? Truly tragic. So here's a real, so before we look at the word problem that we're going to look over, what is the most important real world fact that you need to know about correlation? Correlation, just because two things are correlated does not mean what?
Causation.
Correlation does not imply causation. So here is a problem that I modified just a tiny bit. For a particular brand of potato chips, a market research institute determines a strong correlation coefficient, R equals 0.92, between potato chip sales and toilet paper price. So if you don't understand how correlation works, you might look at this and say, my goodness, if I'm a toilet paper producer, I really need to call up my potato chip selling friends and make sure that they sell more potato chips, because as more potato chips are sold, it's causing the price of toilet paper to go up. That is an incorrect understanding of correlation. Just because these two things are going up at the same time, that does not mean that potato chip sales are causing the toilet paper price to go up, or conversely, that toilet paper price going up is causing potato chip sales to increase. So if we were thinking about this as a